Alright, this lesson is on electrical circuits. We've been talking about energy and how energy transfers, and we're going to really focus in on how electrical energy transfers today. Okay, so how does an electric circuit work? The word circuit, think about a circle. You're going to need to know that a circuit kind of needs to be circular to work. So the wires have to go from the power source, such as a battery, to the device, and then come back again so that these electrons can go out and come back. Okay, so an electric circuit is like a pathway made of these wires that the electrons can flow through, and we call that like an electrical current, that the electrons are flowing. So a battery, such as the one in the picture, or another power source that gives the force, which we'll call voltage, makes the electrons move to get to where we want them to go. Now, I've had this text highlighted in red, so you can write down what I have in red. You don't have to write down what is in the black text. So when the electrons get to a device like a light bulb, such as the picture, your computer or refrigerator, anything that needs power, these electrons, we give them power to work. Many circuits have a switch so that it can be turned and off, on and off. You can see that, when you turn on the lights. There's a bunch of complicated electrical circuits in the walls of our school that whenever we cut on the switch, it gives us light, and if we turn off the switch, it cuts it off. So what the switch does when it is off, it makes a gap in the circuit so the electrons are not able to flow around. The electrons can't flow. You're not going to have that power. You're not going to get, it won't go to the source that it needs to. When the switch is turned on, it closes the gap and the electricity is able to move and make that device work. So let's look at a visual. So switches, once again, help control the flow of electricity through a circuit. So let's look at this picture below. What parts do you notice make up the circuit? You need a power source, such as a battery. You need something that you're trying to make work. You want the electrons to flow to the light bulb to cut it on. And then you have a switch. So now, look at this electrical diagram. Identify which part in the diagram is what based on the picture that you just saw. So I'll go back so you can take one more look. And then let's look here. So on the left, this represents our battery. The bottom, this represents our switch. And on the right, this represents our light bulb. And if you notice here, there is a gap. The switch is turned off, so the electrons can't flow. There's a gap. So here are some symbols, and you may want to copy down some of these. I would not require you to write down the buzzer or the motor, but you do need to know that this is the battery, the wire, the bulb, switch off, because there's a gap, switch on. So I want you to complete these problems on a separate sheet of paper so that I can see what you are learning in this video. So problem number 1, what are the components in this circuit? Will the electricity flow through this circuit? What is missing from this circuit to make it work? And draw a diagram to complete the circuit that will allow the electricity to flow. We are going to do this one together. So looking at A, what are the components in this circuit? You'll notice that there is wire. There's a switch that is off, and that there is a light bulb. So let's look at B. Will the electricity flow in this circuit? The answer is going to be no. First of all, we can look at C. We do not have a battery. We do not have a power source to give the electrons the force to move, the voltage. Also, our switch is turned off. There's a gap. So even if we did have a power source, it would not work because the electrons cannot flow. So we are missing a power source and we are missing a on switch. So draw a diagram that will have those items. I want you to complete the next problems on your own. This is problem 2, so pause. This is problem 3, so pause. And this is problem 4, so pause. There are also different types of circuits. The main one we've been looking at is just a simple circuit. But you can also look at the series circuit and the parallel circuit. So notice that the series circuit, the electrons only flow on one path, just like the simple circuit. They're going to go in this direction. You can also see that we have 2 bulbs here. May need a little extra power source in order for you to have enough electrons and enough voltage to get both of them to work. Notice it also says a break will stop the whole current. So no matter where we cut in this circuit, it could be here, 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 anywhere that we cut will make a gap so the electrons will not be able to flow. Now, parallel circuit has more than one path. So you can see the electrons are flowing in this direction to power that light bulb, and it's also flowing in this direction to power the others. So a break in the wire may not stop all of the currents, all of the electric current that is going through the wire. So for example, I could cut this wire right here. This may stop one of the bulbs, but not both. As well as here, if you were to cut this source, this wire, this bulb may not work or will not work, but this one will because there are more electrons going along this path.